Good afternoon. Today's aim is what is reverse engineering? This is one of the favorite activities of mine in this unit and also for the year. I love reverse engineering. Basically, reverse engineering is where you're taking something apart, looking at its workings inside, see how it works. And normally we'll do it to understand a structure, function, and operation. When I was a kid, back when the Rubik's Cubes came out, I reverse engineered it in order to figure out how to solve it because I couldn't solve it using normal methods. I didn't memorize those algorithms, so I had to take it apart and then put it back together in order to be able to solve it. Um, we can do reverse engineering sometimes to document, okay, if something that we don't necessarily understand, to just make new discoveries, to investigate something that happened, and also to improve products. I love this cartoon right here. This woman's getting into the elevator next to with this other gentleman. She says, "Just a little heads up, Frank. Most Earthlings refer to what you and I are doing as breaking up, okay, not reverse engineering our relationship. Basically, reverse engineering is where we're taking something apart, we're breaking something up. Um, Reverse engineering can be used if there's no documentation. One of my friends, he makes good money get hired by companies in order to write their documentation because when engineers or software folks write software, they don't really like documentation because it's real tedious. It's not the exciting part of writing code, but it's important. So my friend gets paid good money in order to do that documentation. Sometimes we'll document in order to make sure things work together, they operate together, and also something's broken in order to be able to fix it or maintain it. This image at the right that you see here, this computer, was from what they call the Y2K bug. Back in the year 1999, there was a lot of concern that when the calendar rolled over from 1999 to the year 2000, that bank computers would stop working and airplanes might fall from the sky. This was a real concern because back in the 1970s, 1980s, computers weren't nearly as powerful as, let's say, the phone that's in your pocket. So in order to save space in the computers, they didn't store years as four-digit numbers. They stored them as two-digit numbers. So the year 1999 was stored as 99 instead of 1999. So as a result, there was concern that when the year 1999 rolled over to the year 2000, that these computers would roll over from 1999 back to 1900, and then all of a sudden these things would stop working. So nobody was willing to fly on New Year's Eve. People are scared to fly. My friend was a bank manager. He had to show up on New Year's Day, and just to make sure that the money was still there in the bank. We sometimes do reverse engineering in order to make scientific discoveries. They're currently trying to reverse engineer the brain, as you can see here. Basically, why would they want to do that? Well, if you think about it, let's say somebody is missing, an arm, okay, and they give that person a robotic arm. The goal is to reverse engineering the brain so that when the person thinks about moving their arm, because you don't really think about moving your arm, you just move it, right? But when somebody has a robotic arm, they actually have to physically, in order to be able to control it. So the goal is to go reverse engineering the brain so that you can have sensors set up in the brain so that when somebody thinks about moving the robotic arm, then it will just move on its own by just thinking about it. The human genome project was initially reverse engineered. The human genome was engineered really for research and for curiosity initially. But today, the things that are coming out of it, they're trying to cure cancer. They're trying to cure hereditary diseases. So certainly academic research, hopefully will end up helping to cure people and change people's lives. Reverse engineering is sometimes used for military, or very often is used by military and commercial intelligence. The B-29 bomber that you see at the bottom left, three of them ended up during World War II. Three of those bombers ended up landing in Japan because of emergency landings, and the Japanese ended up giving them to the Russians, and the Russians reverse engineered it. They built another bomber that was pretty much exactly like it. It was just quite a bit heavier because they used thicker metal. So they basically built the exact same thing. They just copied it. So at the bottom right, you see an image of a United States drone that this drone was brought down in Iran, and the Iranians were claiming that they were reverse engineering the drone. The U.S. government, if you believe them, okay, the U.S. government claimed that they had a self-destruct mode so that they destroyed all the programming and all the chip that was inside it before it went down. But the Iranians were claiming that they were reverse engineering it in order to be able to build their own drones. Sometimes reverse engineering is used for analysis and testing, or to document patent infringement. Okay, the current and previous U.S. administrations have accused the Chinese government and Chinese companies from infringing on U.S. patents. Basically, they would copy stuff from U.S. companies and not pay for those intellectual property rights. So patent infringement, sometimes they would use reverse engineering in order to prove that somebody copied somebody else's ideas. These two images you see below are examples of forensics, where they're trying to figure out what happened. Let's say in a criminal case. At the bottom left is a picture of a pedestrian bridge in Miami, Florida, that collapsed in 2018 as they were kind of moving it in place. It was built next to the street, and then they kind of rotated it in place, and it collapsed while they were moving it in place. So they did a forensic analysis, research, reverse engineering it to figure out why it collapsed and what the problems were. The image that you see on the right is a reconstruction of the Malaysian airplane that was shot down over Ukraine by Ukrainian separatists. They suggest, that they were backed by the Russians, and the Dutch government actually put several Russians on trial. Okay, for this. So they reverse engineering basically the crime scene in order to be able to prove who caused and who took down the plane and how it was taken down. Reverse engineering can also be used to increase the efficiency of a product, to make it more reliable, to improve manufacturing, reduce cost, increase ease of use, or also to reduce environmental impact. And U.S. companies are forever reverse engineering their competition. So like Toyota or Ford or GM might buy their competitors' cars and reverse engineer it, figure out what the competitor is doing to make their product better or maybe more affordable, and use similar techniques. Some tools that are used for engineering are micrometers, which work very similar to calipers, which you folks have used in class. You see an optical probe here. Medical imaging, such as via X-rays or MRI. How many folks know somebody who's had an MRI? My daughter had one last month because of a fall that she had. Her back was bothering her. So medical imaging, like an MRI, is used in order to figure out what's going on inside the human body, to reverse engineer it and see what the problem is. And you'll see at the right 3D laser scanners. They can also be used for reverse engineering. Reverse engineering involves a visual analysis, which you just did in activity 6.2, functional analysis, which you're going to be doing in this activity 6.3, and in activity 6.4, you're going to be doing a structural analysis later on. So in this activity 6.3, you're going to do a non-destructive functional analysis. We're not going to destroy the item, okay, in order to figure out how it works. And keep in mind, you should be using that same object that I recommended you choose. I said something inexpensive like a mechanical pencil or a pen, that if it does break, if it is destroyed, it's not going to break the bank. If you need to choose something different, that you can certainly do that. That's fine. But something that has at least 3 different parts. But we're not going to be taking it apart for this activity. We're going to be doing it in 6.4. In this activity, you're going to identify, without taking it apart, the purpose and observe how the product functions, and also figure out what its inputs and outputs are. This is an example here. This is an electric toothbrush that, like what my family uses. You may have one similar to that. The purpose is certainly to clean your teeth and gums, to prevent tooth decay, to prevent this frightening dentist that you see here at the bottom left. And also the inputs would include water as well as cleansing paste or toothpaste. This is an example here of an annotated sketch. For your activity 6.3, you're just going to go ahead and do an annotated sketch on paper, and then you can take a picture of it and you can submit it along with your activity in Canvas when you submit the activity. The goal is to devise the hypothesis, how you think the object functions without having to take it apart, and using your sketch as a reference to do that. We're going to be using what's called a black box systems model. Basically, the goal is to identify what goes into the product and also what comes out of it in order to make it work. In the black box systems model, we're using a black box to represent the product's internal components or processes that we don't know. So it's a black box because we can't see what's going on inside it. Okay, it's black because it's dark, so we can't really see what's going on, but we're trying to make a best guess using both the inputs and outputs to figure out what we think it might be doing, how it might be working. And as an example, and you're going to be doing this for number 4 of activity 6.3, you're asked to list the inputs. So the inputs, for example, of a toothbrush, electric toothbrush, are your hand motion, the toothpaste, water, and also energy, the electricity that uses. And the output, some of them beep, some of them play songs, so the output would be some sound. They're certainly going to produce some heat. Anything that has a motor in it is going to produce some heat. There'll be waste, all the stuff that you spit out when you're done cleaning your teeth. And hopefully the best output is also having clean teeth and gums.